Hello everyone, in this video we will make a small animation where these collection of lines would always follow the cursor like this. The second aspect of this is that the intensity of the color or the opacity decreases as the distance of the line decreases from the cursor. So as you can see right now, the top left bars are very faint in color because they are very far from the cursor. So it uses very basic trigonometry, which we'll have a look at, and I'll also give you a theoretical overview before we proceed to the code. All that we need to do is grab the coordinates of the cursor. Let's say that the cursor is at this point right now, or let's say it is at this point. Now just have a look at the very top and very left bar. What we need to do is grab the center of the cell where the bar is, and then just calculate the slope of the point connecting the center of the bar and our cursor coordinates. So let's have a look at small graph. So let's say this is the, you can think of it as wherever my cursor right now is, that becomes the origin. So this is the cursor coordinates, and this, let's say, is the particular bar which we are trying to animate, right? And the x intercept of this will be the x coordinate of this minus the x coordinate of the cursor, right? And similarly, and the x intercept will be the base, and similarly y intercept, that is perpendicular of this right triangle, will be the y coordinate of this point minus the y coordinate of the cursor coordinates. Once we have this perpendicular and base, we know that tan of theta is perpendicular divided by base. So theta would come out to be tan inverse of perpendicular divided by base. Once we get hold of the theta, all that we need to do is rotate the bar by this angle theta with horizontal. That's all that we need to do. Now let's have a look at the code. The HTML is very simple. We just have a div animation space, and all the addition of the bars and cells would be done in this. Coming to the JavaScript code. Size we've given 20. Let's reduce it to 10. You can experiment with the size like this. So if I refresh the page now, the box will be only of 10 by 10 bars. Similarly, 30 is the resolution. That is how many pixels you want to allocate for each of the cells. Each bar is inside a squarish cell. So if I give it, let's say 15, the size, the grid size will still stay 10 bars by 10 bars, but the area that it will occupy on the screen will reduce, right? Reverting them back to the original. Let's keep it 10 for now. The next thing is that we have to initially render the bars, which we are doing inside this function, and then we add an event listener of mouse over on the animation space div. That was this one. So whenever I bring my cursor over this area, it'll do these things, which we'll have a look at later. So coming to the render bars, so we are passing in a cell reference, that's just our array, because we'll be needing this cell reference to realign the bars based on the cursor position. And this is the size, which is 20, or in our case 10 right now, and this is the animation space div. So first of all, we make this animation space div as a grid. This is a sort of boilerplate code which I used AI tools to generate, so we'll not be able to go too much into the depth of it, but just think of it as it is the way to render this grid on inside the HTML DOM. This you can have a look at, like the width is the size, that is 10 times resolution, that is 30 pixels for each of the cell. So this is how I'm setting the width and height of it. And the gap 2 pixel that you see is the gap between the lines that you see right now. And now coming to like rendering the bars initially. First of all, I'm creating a cell. Cell is like a normal div, and this cell will finally be appended to the animation space. So we'll see how to create cell. This again is normal CSS, so I'll skip over this one. Once we have created the cell, we need to create the bar which will go inside the cell. So here you can see we create the bar and then we append it to the cell. Bar, I've given width as 100% of the cell and height as 4 pixels. So the width that you see is actually 4 pixels. So if I just reduce it to, let's say, 1 pixel, you'll see that the bar is now very, very thin. So you can adjust this accordingly. Color I've given red, you can choose any color. And I've given class name as bar because we'll be needing this while fetching it during the realign function. So we'll have a look at it there. Now, we have to randomly rotate every bar. That's what I chose as the starting point. You can also choose to align them to a particular angle, that's fine. So this is the function transform, and then I'm saying rotate by an angle which is in degrees. So angle I'm calculating randomly. So math.random gives a random number between 0 and 1. So multiplying it by 360 will give me a random number within the range of 0 and 360 degrees. So a full circle basically. So that's how I'm initially aligning the bars randomly. Then request animation frame, I'm making use of this function. So my intent here is that for every cell I want to store its coordinates, x and y coordinates, so that I don't have to compute them again when realigning the bar based on cursor position. This is again a boilerplate code which I generated from AI tools. So like this thing, this function, what is inside this function is like we get the rectangle, and then what we are saying is what is the left coordinate of the rectangle. So let's say for the very first one, the left coordinate will come out to be this, and we need to move, and the center of this will be half the width towards the right of the left. Similarly, the center will be half of the height below the top coordinate of the rectangle, and I'm storing both these values inside cell.dataCell.centerx and centerY, these being my custom names. And then once the cell is ready and it has already been appended, bar has already been appended to the cell and the cell has been appended to animation space, I am adding the cell to the cell references, which we'll be utilizing later. So this is about the initial setup. Coming to the alignment phase. So every time the browser detects mouse over on the animation space, it is going to make a call to this align function. This does the aligning of the bars based on our cursor position. So if the grid is too large, let's say 50 by 50, it does show some lag because it has to loop over the 50 times 50 elements. So that's why I've just kept it 10 here for a smooth experience. I'm looping over every cell from the cell references. I get the cell X and cell Y, that is the coordinates which we stored earlier. And then coming back to this trigonometry thing, this is the slope of the line, that is Y, and Y minus cell Y. Y is the Y coordinate of the cursor. If we have a look at where this method is called, we are passing X and Y, and X and Y are captured from the event, the mouse over event, client X and client Y. So these are the coordinates of our cursor. So it's essentially y1 minus y2 divided by x1 minus x2 in geometry terms. So we get the slope of the line connecting my cursor to the center of each of the cells. Once I have the slope, again using this formula, P by B is the slope that we've calculated. We just need to take tan inverse. That will give us the angle with the positive x-axis or the horizontal axis. So here I'm doing math dot inverse tan of slope. This gives angle in radians, so we need to multiply it by 180 divided by maths by pi to give the angle in degrees. Once we have the angle, we just rotate the bar by that particular angle. And bar also, we know that it is a child of the cell div element that we have. So I'm making a use of this method, get elements by class name, and that's how I get the bar and I rotate it. So this is till the point that how the bars are aligned. Now coming to the gradient, so the bar which is very close to the cursor is always going to have highest opacity, and as the bar's distance increases, the opacity will reduce. So this is the formula I'm using. Distance is again x square minus y square and the under root of entire thing. So math dot square root of y1 minus y2 whole square plus x1 minus x2 whole square and the under root of entire thing, that is math.sqrt. So we get the distance, and then I'm setting opacity as 1 minus distance divided by maximum distance. Maximum distance is the distance of, if I bring my cursor to the one corner, what is the distance of the extreme opposite cell, diagonally opposite cell, that is the maximum distance. We'll see how that has been calculated above. But initially, if the distance is 0, that is your cursor is inside the cell where the bar is, then it would become 1 minus 0 divided by something, that will be essentially 1. So it will stay 100% opaque. As the distance increases, this fraction will increase. So 1 minus this increasing fraction will result in a decreasing value. So as the distance increases, the opacity will also decrease, as you can see visually. Now how max distance is calculated is just like the max distance is nothing but the length of the diagonal of this box in pixels. And diagonal is square root 2 times the length of the box or the edge of the square. And what is the edge of the square? That will be number of cells on this edge times the pixel occupied by each cell. So, and these two values we already have, size and resolution. So size times resolutions times square root of 2 is how we're getting the maximum distance. So that is it about this animation. As I said, let's make it to 20, or let's say 15 to increase the size a bit. Now the second variation of this is instead of moving it by angle, if we just move it by angle plus 90 degrees, what we get is a completely different animation where the lines would not point towards the cursor, but they would align themselves in a way that they will be perpendicular to the line connecting the cursor and the bar, like this. I hope it was useful. Thanks for watching. Bye.